I would firstly like to extend my gratitude and welcome our judges for the Mathematics Deep Thought, Professor Steven Spallone and Dr. Abhaya Basu. They have been present throughout the verification and framing of the questions, and I would like to thank them on the behalf of the question-making team. We have our finalists, IISc, IIT Bombay, IIT Delhi, and IISER Kolkata. And now for the audience, the participants and the judges, I will very quickly go through the rules. So the deep thought will be for 2 hours and 30 minutes. There will be 4 questions. The first or the directed team will be selected through the draw of a chit. The chit will be drawn by our judges. All the teams will have 15 minutes of thinking time, wherein they'll be able to work on the solution, but they won't be allowed to present on the board. After 15 minutes are over, the first team, that is a directed team, will get 5 minutes to present the solution on the board. Subsequently, the next team will get 3 minutes and the other 2 teams will get 2 and 2 minutes each. After one question has been completely presented by all the teams, the judges will ask for clarifications and ask any questions, and then a member from the question making team will come to the board and present the solution. The maximum number of marks a team can get if they answer the directed question correctly is 15, followed, if the first pass question answered correctly, it will be 13, followed by 11 and 10. Apart from this, I would also urge all the teams that please do not repeat solutions which have already been presented by the teams. Add new information. If you, I don't think you have any clarifications because we have already done this once. So without wasting any more time, I hand it over to Yashika and Satyam, who are the Maths Deep Thought podium coordinators. Thank you very much.
Good evening, everyone. I welcome you all to the Math Deep Thought of Mimamsa 2025. My name is Yashika Bhatla.
My name is Satyam. We are the podium coordinators for Deep Thought Maths.
We'd like to introduce our judges for the evening. We have Dr. Abhaya Basu and Professor Steven Spallone. Dr. Abhaya Basu is an associate professor currently working on algebra. She joined IISER Pune in 2010. She obtained her PhD from TIFR and was a postdoctoral fellow at HCRI Allahabad and at IISER Kolkata.
Steven Spallone is a professor at IISER Pune who is currently working in representation theory. He got his PhD from University of Chicago. He was a postdoctoral fellow at Purdue and University of Oklahoma, and he joined IISER Pune in 2012. We thank them both for being here. We request our judges to pick chits to determine which team gets to answer a question first, and will move clockwise from there on.
So the team going first will be IISER Kolkata, followed by IISc Bangalore, followed by IIT Bombay and IIT Delhi. Presented on the screen are 4 questions: collapse conjecture, cut the rope, outrageous GP farm, earning your balls the hard way. IISER Kolkata, which question would you like to choose? Ruta and Yashika play a game of cut the rope, where they cut ropes of 2 distinct colors, one after the other. The ropes are hung from the ceiling, so when they cut a rope, that rope and all ropes below it fall. The rules of the game are as follows. The players can only cut ropes of the assigned color. The last player to play a move wins. Refer to the figure for position. Yashika will play first with blue ropes. Assume both of them are extremely intelligent and will play optimally. Who will win this game of cut the rope and why? Do you have any doubts? IISER Kolkata, your time starts now. Teams, you have 5 minutes left. Teams, you have 3 minutes left. Teams, you have 1 minute left.
Teams, your time is up. IISER Kolkata, kindly come up to the stage and present your answer. You have 5 minutes, and your time starts now.
So, as we can see, if we count the number of ropes that are there are, for the red ropes, there are 6 in the first one, plus 7, plus 1, plus 3, plus 5, plus 7, plus 9, plus 11. If we count the number of blue ropes, 7, plus 6, plus 2, plus 4, plus 6, plus 8, plus 10, plus 12. So what that means is basically that there are 6 more blue ropes as compared to the number of red ropes. Now, if Yashika starts cutting from the exact top, suppose one has been cut, then the strategy being that Ruta will get less number of ropes to cut, then immediately Ruta can cut the red one, and in this process, after cutting each one of them, what we are left off with a blue one, red one, blue one, and in certain fashion a blue one right here. So all the pairs will get exhausted, and the blue one, the last blue one, if he cuts, then immediately, thanks. The blue one, if she cuts, the red one will be cut next and Ruta will win. But because they are intelligent, obviously what will happen, this is not gonna happen. So what instead Yashika can probably do is, this is the red one, after which there is probably one blue one. So Yashika would want to waste a chance over here by cutting the blue ropes, the subsequent blue ropes, all of them below the red one, so that on the red one being cut, now the zugzwang is on the other person. So now after the red one is cut, then blue gets an extra chance, which means eventually in this way what will happen is that blue will start cutting from the exact bottom. When they cut from the exact bottom, now what happens if red cuts the topmost, suppose, so the chance is again given up to the other person. So red will also start doing the exactly same thing from the exact bottom, which means that the person who has the more number of ropes would win this, which is basically blue, Yashika. Yashika would win it. Thank you.
IISc Bangalore, you can now present your answer. You have 3 minutes and your time starts now.
I will basically explain my idea. So here we can see that in the first row you have blue, red, and so on. In the second row we have red, blue, red, and so on. Basically what we do is we can see there are I think there are 14 total lines, and basically my idea is we try to pair up these lines. Sorry, not this. Except the first line, I try to pair up the second and third line, the fourth and fifth line, the sixth and seventh line, and so on. And if we see a general configuration, then there will be something like, okay, if we in an even numbered position, the first element will be red and rest all of them will be blue. And in an odd numbered position, first element will be blue and next all elements will be red with one extra red. Now thing is, I will try to pair up the moves. If Yashika plays this, Yashika will play a blue move. If Yashika plays this, I will play this. If Yashika plays some blue move here, suppose some n number of blue strings are there. There is one blue string. Suppose Yashika plays some move like this. Yashika can play either this move or some blue move in this line. If Yashika plays some move in this line, what I will do is I will keep an extra red I will keep a one lesser number of red, and I will remove the earlier red one. Sorry. I will remove this red. Basically, if we remove the n+1th blue string, I will remove the nth red string. And this way I will maintain the opponent.
1 minute
this way
left.
the opponent will maintain Yashika in a losing position. Okay, now I try to pair up the first one and the last, first string and the last string. We can see there are the total length is 30.
Your time is up. IIT Bombay, you can now present your answer. You have 2 minutes, and your time starts now.
So basically, first Yashika will start. So she will cut off the first row, the blue red alternating one completely, followed by Rutu's chance. Whatever Rutu cuts, Yashika is supposed to cut there are 6 buffer ropes that we have. So she can cut any one of those last terminal 6 rows, whichever she finds, she can cut any one. And following that, whatever Rutu does, she can do a complementary move, so that in the end, Yashika will have one last blue rope remaining.
First Yashika cuts this one, and then first Yashika cuts this one, and then like we have a buffer of. We earlier had a buffer of 6 moves for Yashika, but now this line has 1 extra blue, so we have a buffer of like 5 ropes. So whatever Ritu cuts, we cut like any one rope from where we have 1 extra. Like in the last time we have 1.
Team, you have 1 minute left.
We cut that one, and then we just cut corresponding ropes, whatever it cuts in. Like we form pairs, and we can form pairs like this. And whatever Ritu cuts, we can just cut corresponding number of ropes, and then
And in the end, the last one will be cut by Yashika.
IIT Delhi can present your answer. You have 2 minutes, and your time starts now.
okay, so the first turn which Yashika makes is the last cut of the last subset, the nose down of the last one, and then as Ritu cuts any red, we will define two types of ropes, one that is attached to the ceilings and one that is hanging from the ceiling. So the hanging blue is much greater than the hanging from the red which is hanging. So after the first turn, if Yashika cuts any hanging rope, if Ritu cuts any hanging rope, Yashika will always have a hanging rope to cut, and if if Ritu cuts a rope which is attached to the ceiling, Yashika will also cut a rope attached to the ceiling. And so in this case, Yashika will always be guaranteed to win it. Like first Yashika will cut here. If Ritu cuts here, Yashika will cut somewhere here. And if Yashika cuts this, Ritu will cut the corresponding hanging. And since the number is 7-7, so the last rope is always Yashika will cut. So Yashika will win the competition.
The floor is now open for questions from the judges.
No questions actually.
We request a member from the question-making team to present the correct solution.
Okay. Yeah. One second. Attach this. No? Try to attach it. Does this work? Oops. Put it here. All right. Is it visible? Okay, perfect. Right. So, what we're going to do in this question is actually we're going to take the simplest case possible actually first. That is if you just have a blue and a red. Well, if you start from this, you'll notice that blue starts, oh sorry, let me just change the color. Oh. Yeah, blue starts, red wins, right? Huh? In what? Yeah. Oh, it's equivalent. Wait just one second, we'll just get back to that. Okay, so if you cut this, this happens. If you take the same case again, so okay, I'm just going to draw this quickly. Over here, again, if blue starts, no matter what blue does, red can always just play something over here. And now blue is supposed to do this, and red is this. In both these cases, red wins. Now we're going to do induction on this and prove that no matter what, red will always win. We consider any large even case. So there are two cases here. If you have an even height, then we break it down like this. We create these two boxes, and now the only possible moves are if blue takes this off, red takes this off, and we have reduced it to one size down. And by induction, that is solved. If blue plays here, red will cut this off, and you got two regions here. In this region, red wins because by induction, and in this region, red wins because you can simply mirror. Blue plays here, red plays here, blue plays here, red plays here, red wins. You mirror in this strategy. And if blue happens to start inside, you already have a solution in the box. Just play that accordingly by induction. The odd case gets slightly trickier, but no matter where blue plays in here, your move is to simply cut. If blue plays anywhere in here, you just cut this off. Reduced case, if blue plays somewhere here, you still cut this off. And now you have two smaller regions. You have this region which is solved and this region which is also solved. And last case, if blue happens to play somewhere here, then you cut this thing off and again you have two regions. In this region it's solved and the outside region red will win. Solution. So odd, even, and yours was 13. By induction, the problem is solved. This is a coupled game. The one who starts always loses. Yeah. You want to talk about the actual? Yeah, just explain it once quickly.
Okay.
Just talk about it quickly. You don't. You can just explain.
Okay. Wait.
Just
Okay. There's also another method which you can solve using game values. So what you do is if there's one red over here and this is here, you call the red game value as +1 and this game value as -1/2. Because if there are two structures like this, and then, yeah. So you can solve it using game values, you just assign them 1 and -1/2 if anyone knows that.
I see Bangalore. Which question would you like to choose? Collapse conjecture. Saroj has a crush on one of his friends, but is too shy to ask her out. Instead, he creates a game of his own to find out if she likes him back. He concatenates both their names and converts it into a binary string using some arbitrary method. Then he does the following transformation on the string. If the string contains a stretch of n consecutive ones or zeros, substitute that entire string with the binary representation of n. Example, the string 0, 1, 1, 1, 0, 0 has 1 consecutive 0, 3 consecutive 1s, and 2 consecutive zeros. So it will be mapped to 1 in binary, 3 in binary, 2 in binary, that is 1, 1, 1, 1, 0. He iterates this function infinitely. He hypothesizes that his crush likes him back. Then the string will be caught in the cycle 1, 0, 1, 1, 1, 0 in a finite number of iterations. Prove that Saroj has rigged the game in his favor, specifically that any string of length greater than 2 will be caught in the cycle 1, 1, 0, 1, 1, 1, 0 in a finite number of iterations. Do you have any questions or doubts? Will be caught in that cycle, as in that will repeat. Okay. I see Bangalore. Your time starts now. You guys have 5 minutes left. Three minutes left. Only a minute left.
Teams, your time is up. IISc Bangalore, kindly come up to the stage and present your answer. You have 5 minutes and your time starts now.
So any pair will be like, there will be x1 numbers which are equal, some x2 numbers which are equal, a block of x3 numbers which are equal, and so on. Some block of xk numbers which are equal. Basically, what I mean is some blocks of zeros or some blocks of one. It starts, the pair starts, and it goes on. There is some blocks of zero, then there is some block of one, or the opposite case. Then what I do is, okay, we will try to prove it by induction. Base case, we can see base case is obvious. Now the thing is, basically this will transform to x1 base 2, x2 base 2, and so on. My claim is any number x1 in base 10 has, in binary, has at max gif of log of x1 base 2 plus 1 digits. And my claim, and then after the transformation, the total number of digits in this sequence will be summation gif of log of xi base 2 plus 1. Now my claim is gif of log of xi base 2 plus 1 is less than equal to xi for all xi belongs to natural numbers. If this happens, then by this inequality we will have that summation of gif of log of xi base 2 plus 1 will be less than equal to summation xi. Summation xi was the initial total number of digits. Summation log of gif of log of xi base 2 plus 1 was is the number of digits in the next transformation. You explain the proof of this.
Here I have proved that after n equals to 1 or 2, 2 to the power n minus 1 is greater than n, which if you want to prove, you can prove by Bernoulli's inequality. Then if you take log 2 on both sides, you have n minus 1 is greater than log 2n. So log 2n will be greater than or equals to greatest integer function of log 2n. So so log 2n greatest integer function is bounded by n minus 1. And for n equals to 1 or 2, equality holds. So the inequality is always 2.
So my claim is after some number of steps, the total number of digits in the sequence will definitely decrease. Suppose not. So it means this here there should be equality. We will try to analyze the equality case of this inequality. Equality holds when xi is equal to 1 or 2. So it will mean that the sequence will always stay in this form, binary representation of some blocks of 1 base 2, some blocks of 2 base 2, some blocks of 1 base 2, and so on. Or it will be something like some blocks of 2 base 2, some blocks of 1 base 2, some blocks of 2 base 2, and so on. Okay, let's analyze this case. Suppose there are x1 number of blocks of 1, x2 number of blocks of 2, and so on. Then the sequence will look like some x1 number of ones followed by 1 0 1 0 1 0 2 x2, because a binary representation of 2 is 1 0. After this same 1 1 and so on. So so you can see there will be x1 plus 1 number of ones initially. After that there will be 1 0. After that there will be 1 1. And here we are assuming x1 is greater than or equal to 1.
30 seconds left.
By symmetry, the other case will be similar, because the only thing that matters is the number of times this appear.
I see Bangalore, your time is up. IIT Bombay, you can now present your answer. You have 3 minutes and your time starts now.
So, first, I'll be taking case 1. There is a binary string. It is mapped to some strings where A1, A2, and these are all in decimal numbers, like they are not zeros and ones. So, case 1, sum AI is greater than 3. So the binary so it takes like a block of length 3 here, but the binary expansion of 3 is 1 1, which has a length of 2. And for all numbers greater than AI, the binary length of binary expansion is less than the number itself. So the string decreases in size if there is some AI greater than 3. Then case 2, there is no AI greater than 3, but we have 2 consecutive ones. So if we have 2 consecutive ones, next one, AIs are all like natural numbers. So next one has to be either 1 or 2. In this case, the length of this part would be 1, 1. Like when we convert it to binary, it would be 1, 1 and 1. Next would be 0 or something else, because both 1 and 2 have first binary digit as 1. This would in next iteration cause an AI to be greater than 3, which would give us this case only. So this string would also later on collapse. Then I take case 3. We have 2, 2 dash, like for some AIs. This would have a binary expansion of 1, 0, 1, 0 and something. This has to be 1 because again 1 and 2 both have first digit 1. So this would give a next case of 1, 1, 1 for corresponding to this. This I'm not considering. So here again next case would have AI greater than 3. No, this would give us like this case which we already solved when we have 3 consecutive ones in AIs. So this string would also collapse. Case 4, we have alternating of 1, 2, 1, 2 starting from 1. This would give a string like this 1, 1, 0, something like this, which is 2, 1, which then maps to 2, 1, 2, 1 and something. This is my case 5. Now case 5, we have an alternating string starting from 2. We get this 1, 0, 1 and something like this. So it has, when we convert it into
You have
like,
30 seconds left.
we map it, we have 1, 1 and then something, which whatever it is. So we again get 2 consecutive ones, which is solved here. So case 4 and case 5, these 2 strings also collapse. Hence every string at some point of time collapses to a length of less than whatever it is. So for base case of length equal to 2, we have solved it here. And for any case greater than 2 length, this.
IIT Bombay, your time is up. IIT Delhi, you can now present your answer. You have 2 minutes and your time starts now.
So suppose we have any sequence that starts with either 0, it can start with either 0 or with ones. It could be anything. My claim is that after one round of converting this string to binary, it will obviously start with 1. Like after the first step of converting it in modulo and doing things after that. So after doing this, assume the length of each sequence is like AIs, A1, A2 or A3 or whatever. If AI is not equal to 1, that is it is 2 or greater than 2, what my claim is that its length, which is AI, when it is converted, when it is counted and when it is converted back, its length, this thing is always like works. It is less than equal to AI. For AIs greater than equal to 2, and the equality is occurring at 2. What basically I'm saying is that after operations, like this, its length is A2, and after some operations, whatever the length of it will be, if AI is greater than 2, it will always reduce. For AI equal to 2, the length will revolve around 2 only. But so basically if AI is equal to 1, its length will remain 1, and for AI equal to greater than 2, its length will keep reducing until unless it reaches 2, where it will cycle like 1 1 1 0 or something like that.
IIT Delhi, your time is up. IISER Kolkata, you can now present your answer. You have 2 minutes and your time starts now.
That any sequence, any random sequence of one and zero, that means or saying that if we take any sequence and do that process, we will get that after doing the process, we will get that the length is actually decreasing, because the thing is, if for example, if we take any number and the repetition, suppose there are 4 ones, so basically they will be mapped to 4, and that length will be less than that, because basically n is basically less than 2 to the power n minus 1. So if it's finishes with 0, so it doesn't matter. So it is equivalent, because these and these are same, so it doesn't matter. So what matters, that it will finish that sequence with finishes with the number 1. So if it finishes with the number 1, so then actually there is a coefficient of 2 to the power n minus 1 there. So, but n is less than that, so that doesn't that is not possible. So obviously the length will be less than that, and if the length is decreasing, then the length will be goes to generally goes to the length of the sequence, any arbitrary length will go to sequence of 2, and if it goes to sequence of 2, it will be either 1 0 0 1 and that thing, and in the and 1 1. But both the cases, if we perform the process, we will get the thing to.
Basically, what we are saying is that if at the end we have 1, then we will have a coefficient of 2
30
to the
seconds
power
left.
n minus 1, and n will be less than that, which is not possible, which is why we will reach this type of 2-digit ultimately, and then we fall into this trap of the zugzwang, like 1 0, binary expression is 1 1, and from there again from 0 1 it is 1 1, so we fall into this continuous loop of 1 0 to 1 1 to 0 1 and so on. Thank you.
Okay, no questions right now. Thank you.
We request our core team member Saroj to present the solution.
Use the mic actually.
Can I erase this?
Hello. Okay. So first of all, there are a couple things we'll notice that whenever we have any binary sequence, we can always assume it to like start from 1, because complements doesn't really matter. After you apply the function, whatever transformation you are doing, you will get 1 starting with 1 anyway. So we don't care about complementary. Yeah, so whenever we have like any sequence greater than 2, so any repeating sequence like 1 1 1 or 0 0 0 or anything greater than this will obviously go to 3, which is in base 2, which is 1 1, and similarly this will go here. So anything greater than this will collapse. That much we know. So what we really need to care about is the sequences of basically the repetitions of the form, say 1 1. So this is 1 repeating, then this is something repeating 1 time, something repeating 1 times. Then you have something repeating 1 time, something repeating 2 times. We'll make cases like this. And wait. Yeah, yes. And then we'll deal with how to collapse these. So 1 1, there are 2 cases in 1 1. First of all, if say it appears like this, not at the end, right? Okay, it doesn't appear at the end, so there's something after it, and there can be something before it, or it could just be at the start. So what you will note is that since this is a repetition, like the repetition ends here, like there must be something here, and when it converts to binary, it must start with 1 further on. So this will go to 1, like okay, this should be something like 0, and this will go to 1, and here also there you will get a 1. Since we got a continuous 3-gas or greater than 3-gas sequence, it will collapse. Then we go to the case for 1 comma 2. 2 2. Okay, fine. So in the case of 2 2, let's say we have 1 1 0 0, and we don't really care where it appears. So this will collapse to 1 0 1 0, and yes. So suppose it ends here, then this will convert to 1 1 1, which ends the thing. Suppose there's something else here, since this repetition is like, if it must be 1 because of our previous arguments. So again we will get this, and hence, so 2 2 case is completely done. 1 1 we have done partially when it's not at the end. We'll come back to it later. Wait, duster is this? Yes. Yes, now which case? 1 2. Okay, now we go to case 1 2, which is like this. Undo mein case nahi hai? Okay, so 1 2 not being at the beginning, which means it could be at the end or it could be at the middle. So in that case, you will get, first of all, this will get converted to 1 1 0. Now, when it's not, since it's not at the beginning, not at the beginning or not at the end, not at the beginning, we could get a 1 here, or we could get a 0 here. There are 2 possibilities. If we get a 1 here, then we are done. If we get a 0 here, this is sliding case? Okay. If we get a 0 here, so yeah, so then we consider the next step of the transformation. This will go to 1, this will go to 1 0, and this will again become something we don't know about. So here we can say it might be 0 or it might be 1. If it's 0 here,
So here he did a little mistake. So in this case it completely solved. So if it is 0 1 1 0, then so you see at the beginning there might be something here. So this thing maps to a number. So we what we do is we disregard the first bit, last bit, because it can be 0 or 1. This thing transforms to 1 0, and this thing must be 1 because of the again previous arguments. So if this thing again a 1, we get 2 1 case back, or if it's even better for if we get 3 1, so we don't care about that. If it is 0, again we get 1 1 case. That's even a better case. Yeah, and so this thing is this thing, if it's on the beginning, that's how the series ends. this thing is 1 0 and we start with 1 and now it will transform again to 1 1 1 and then we are done. So this is problematic is this 2 1. So it's similar but not exactly the same. This is what IITB tried to show here. It would be like this 1 0 1 and then either 0 or the 1 at the beginning. If it is 0 at the beginning, we get 1 1 1 case. Else we get a 1 1 0. So it's again a 2 1 case. Sorry. Again a 2 1 case. So this 2 1 case, but see one thing. This 2 1 case is one bit slid forward. Hello? So this one bit sliding forward of it will continue until we hit the start of the sequence, or we hit a 1. So we see if this kind of a thing 0 1 1 0, we slide forward, else we end. So can be always zeros, but it can't be always zeros because sequence is finite. So we end, we go to the very start. When you go to the very start, there is nothing, so we end. And the sequence again length decreases. Just 1 1 at the beginning case is even simpler actually, and look like something like this. It will map to something like this, and again this would either give a rise to case 2 1 or is 2 2, simpler cases.
1 2 at the beginning.
1 I want to I did it. Yeah.
IIT Bombay, which question would you like to choose?
Earning your balls the hard way.
Earning your balls the hard way. Akshat and Pada like playing with balls. In this game, they pick a hollow cylindrical tube of length n and diameter 1, along with identical porous balls of diameter 1. They divide the tube into n divisions of length 1 and label them C1 to Cn. Every minute, either of two signals get lit, red or green. If the signal is green, Akshat shoves one ball into the tube from the right into Cn. Since each division can only hold one ball, if there is already a ball inside a division and another ball tries to enter the division, it gets pushed to the division on its left. If the signal is red, Parda shoots a hook into the tube and pulls out the ball nearest to him. If k is the number of balls in the tube at a time, then p green is 1 minus k by n, p red is k by n. Given the two people have been doing this task for a very long time, what proportion of time is a division Ci filled with a ball if, question 1, Parda is standing on the left end of the tube, question 2, Parda is standing on the right end of the tube? Do you have any doubts? Your time starts now. Teams, you have 5 minutes left. Teams, you have 3 minutes left. Teams, you have a minute left.
Teams, your time is up. IIT Bombay, kindly come up to the stage and present your solution. You have 5 minutes, and your time starts now.
Yeah. So first question papers. First, we can see that we have been given that we have to figure out the proportion of time when division Ci is filled after a very long time. So we can assume that if they are playing this for a very long time, then at some point of time the tube would be completely full. So for A part, there would be a time where all are full, and similarly for B. Yeah. So now we can see that whenever a ball is taken out, it is taken out from the leftmost position here, and in this case, it's the rightmost position. Whenever a ball is inserted, we can say that like it would be suppose a ball is inserted, and if it would be like we can insert it from here, and it would go all the way to in. It would be like because there are identical balls. Suppose this one and this one are filled, then the next ball is can be technically considered to be inserted here. So when the ball comes out, it would come out from this position, and in this case also, like suppose these two are filled, the next ball is technically inserted here. When the ball comes out, it would be this one. So by this we can see that whatever answer we get for A part for Ci, it would be the same answer which we get for B part for Cn minus I. Then we get this equation n minus 1 by n, sorry, n minus k by n pk plus k plus 2 by n pk plus 2 equal to pk plus 1. Now pi is basically the ith pi is basically a point of probability that exactly I balls are there. Now how I got this equation is that suppose there are k balls, then in the next iteration the possibility of getting pk plus 1 balls is n minus k by n pk, and if there are k plus 2 balls, then the next iteration we get k plus 2 by n pk plus 2. So adding them we get this equation. So the probability is like for exactly I balls we can get from this, and then the answer AI is sigma I j equal to I to n pi, which is basically like ith for B part. The ith container C1 is filled when there is exactly one ball in this, one or more than one ball in this tube. C2 is filled when there is two or more than two balls in the tube, and so on. So basically AK can be taken to be exactly K or K plus 1 or K plus 2 or up till n balls, which gives us PK plus 1 up till n, which is this equation. So for B part, we get the answer this way, like after getting close from for pi, we can put it in this to get the answer, and from here, like once we get the sorry, this is B. For the answer of B, we put it here and we get the answer for B part also, which is symmetric. A and B are symmetric for n minus I and I. और कुछ अक्षर? Yeah, he has written the same thing, and just like he has taken pk plus 1 to be ti. What?
So it's the same thing almost. If
30 seconds
I have
left.
defined ti as the time, a fraction of time when I position is when the minimum, I position is the minimum value where ball is. So like this for the case A, I am telling. Nahi, minimum. No,
So we can go to the I position from either the I minus 1 or the I plus 1. So and the probability, if we are at the I plus 1, we need a red color
IIT
flag.
Bombay, your time
And if
is
we
up.
are at I minus 1,
IIT Delhi, you can now present your solution. You have 3 minutes and your time starts now.
That the ith So once we get the value of x, we can find a direct expression.
So as the problem suggests, that what we have to do is we have to insert the balls from the right and we have to take out the balls from the left in the solution. So the probability of the ball being in the Ci division is equal to the probability of the ball being in the I minus 1, that is in the right of that, into 1 minus I minus 1 by n, that is the probability of the green light glowing, because at that time there are I minus 1 balls over there. And when the red light is being shown, that means there are eyeballs over there, so pi into I by n. So that means we have this recurring solution 1 minus I minus 1 by n, but then pi minus 1 is equal to 1 minus I minus 2 by n into pi minus 2, and then in the similar fashion. So we get a complete recurring solution till n, which we, if we solve, we get I to the power I I n c n c I minus 1, I n c I minus 1 upon n to the power n. That is the answer for us.
IISc Bangalore, you can now present your solution. You have 2 minutes and your time starts now.
Suppose after some time, the probability of the ith portion getting filled by a ball is P of I. Then clearly, if there is a green ball, then if there is a green signal, then another ball will get added, and the probability of a green signal is the probability of a green signal while there are I minus balls are 1 minus I minus 1 by n. So P of I will be P of I minus 1 into 1 minus I minus 1 by n, plus if there is a red ball, if there is a red signal and there were I plus 1 balls at first, then P of I plus 1 into the probability of getting a red signal, which is I plus 1 divided by n. I plus 1 divided by n. Now what we try to do is trying to find a sequence solution to it. So suppose this is ai equals to ai minus 1 into 1 minus I minus 1 by n plus ai plus 1 I plus 1 by n. Then continue.
For a particular solution, we have to guess a solution assuming a random I, and for a homogeneous solution, we put I equal to 0 and
30
proceed
seconds left.
forwards, and then get a solution. For obviously, we can assume x a to the power I equal to some x ai equal to some x to the power I. Cancelling terms, we'll get a quadratic. Solving that, we'll get pi, and pi is proportional to the time which is required, and we couldn't solve any further.
The floor is now open for judges to ask any questions. Do they have any questions? Okay. We request a member from the question making team to present the correct solution on stage.
So please go. I'll explain the first part of the part one of this question. So if you look at the tube, it's like this. The balls are getting added to here and leaving here. So when a ball gets added here, it comes here and then no, that's fine. And then and if it gets taken out, the left modes get taken out. So you'll probably notice by that from here that whatever balls get added here and then they get taken out and they're added and taken out and taken out. Whatever balls are there, they're all on the right side, just stacked on the right side. So if you want to find out the push for the ith compartment, you just have to find out how many balls, what proportion of the times there are certain number of balls there. So the first part just reduces down to how many balls are there, regardless of order. So we want a recursion, right? So let's say at I'm writing the probability that there are k balls at time t plus 1. That's just the probability that there were k minus 1 balls at the tth time, and a ball got added to it, which would just be which is just k minus k plus 1 by n plus the probability that there was k plus 1 balls at time t and a ball got taken out, which has a probability of k plus 1 by n. Now, in the long term, this time doesn't matter, so let's just take out the time part of it. And this is the recursion that we get in the long-term stationary case. Now, what we do is we pull out the n, we put it thoda sa, multiply it all by n. What we get is n p k is just k plus 1 okay, let's just write this as pk, and this is pk plus 1 plus n pk minus 1 minus k minus 1 times pk minus 1. I'll take this guy and this guy with her, so I'll get n pk minus pk minus 1, that's which is equal to k plus 1 times pk plus 1 minus k minus 1 pk minus 1. Now if you notice here, these are the same indices, this is the same indices. This helps because now we can sum it up over all possible k's. And what happens when you do sum it up over all k's is that we'll get a telescopic sum. So if you sum up, if you do a telescopic sum of this and if you do a telescopic sum of this and you come to it, then what you get is basically n of pk. You get the last two, everything in the middle gets cancelled out and the last two, first and the last term remains, which is n p0 is equal to just k plus 1 pk plus 1 minus p1 plus k pk. Now we'll have to take a certain base case. P naught, the only way to enter P naught was from the place of 0 balls. The only way to come from there is if we had 1 ball and that got taken out. So you had the property of 1 ball and that 1 ball got taken out, which is just 1 by n. So we get P naught equals to P1 1 by n. You put this here and you put this here, you'll get n minus k pk equals to k plus 1 pk plus 1. Now we have a recursive formula, and if you keep iterating it, you will see that this you can write in terms of this and you keep getting it. So what you end up getting from here, you get pk. If you keep iterating that term, you will start getting n minus 1, n minus 2, and so on till n minus k plus 1. The whole thing divided by k factorial times p naught. This is just your usual n choose k times p naught. Now we know that the number of balls could range from 0 to n. So if you sum up this thing, so if you sum up all the pk's from k equals to 0 to n, you should end up with what? Because that's the entire sample space. This is just this, which implies summation of k naught equals to 0, say n choose k, p naught is equal to 1. You take this guy outside. This thing is a combinatoric summation, which is just 2 to the power n. So what we get is 2 to the power n p naught equals to 1. Take it here. You get p naught equals to 2 to the power minus n. And you put this here. Sorry, you put this here. You get in general that pk is just n choose k 2 to the power minus n. And this pk is again just the probability that there are exactly k balls. Now if I want for a certain position, like I said, for a certain position, let's say I wanted the ball, how many times the ball is in this position. This slot will be filled if there were 3 balls, 4 balls, or 5 balls, or any number of balls greater than 3. So what you want in the end is just the summation. In the end, what you want is just the summation from this all the way to the end, which just turns out to be summation of k equals to j n choose k divided by 2 to the power n. That's the solution for part A. Now coming to part B.
Yeah. Part B. ये तो part A था sir. So in the part A, the most important observation was that all balls are stacked to the very right. In the part B, as balls like inserted from the right and also removed from the right, these kind of things don't happen. There might be gaps. So all 2 to the n possible states are possible, at least reachable. So now what we do is we represent a state as an n-bit binary number, x. Like n-bit binary number, let's say call it a. And so
we see one very important thing, that when you add to a number, add to a state, the ball get inserted to the rightmost empty position because the ball slide. And when you remove from a state, that gets removed from the rightmost full position because again. So if we take the complement of A, what happens is, let's see if this state, there are balls here and here and empty slots here. Now if we remove from here, we'll get this empty ball, empty, empty and empty. If we take its complement, there's a ball here, empty, ball, empty and ball. And if we add one here, the ball will get added to the rightmost empty slot, which in the complement is the rightmost full slot. So this is our main point. Add to A is equivalent to removing from A complement and take its complement. This is the most important point. From here, almost everything easily follows. Just a pass correct. Yes. Also, let's see. So let's say A, from state A go to state B and state C. This by addition, this by subtraction. So this probability of this thing happening is 1 minus k by n if A has k balls, and this is k by n. Let's see what about AC. We see that while adding, we just proved there. While adding, we just get to state C, and removing, sorry, C complement, and by removing we will get to B complement because of that. What's the probabilities of this thing? This thing is 1, this is n minus k balls, this is 1 minus n minus k by n, which is k by n. And this thing is 1 minus, sorry, n minus k by n, which is 1 minus k by n. So we see the probability of A going to B and A complement going to B complement are exactly the same. From here we can argue that the probability of A is equal to probability of A complement. This is because let's say it is also because one observation that from the previous one also follows. Previous one gives you the probability that there are k balls. As there are like all balls stacked together, these exactly give us the state probabilities. Here, so they don't exactly give us the state probabilities because there might be multiple states with same number of balls. So, but still, there are only one state with k equals 0 balls and k equals n balls, full and empty states. And from the previous one, we see that both of the probabilities are 1 by 2 to the n and 1 by 2 to the n. So, probability of origin state and probability of co-complement is the same. From this, as the paths are all the same, we can go to A and O complement to A complement. As their same paths reverse with same probabilities. These must be the same, and from it we just get the probabilities of the one state, that one bit being on, because probability of J being the jth bit is on. This is sum over all probabilities such that A का jth bit is on. But if A jth bit is on, we take the A's complement, this jth bit is off. So if we take 1 minus pj, that is, there should be A's jth bit is off. And which is exactly A complement, sum over probability of A complements, which is from here same. So pj equals 1 minus pj. That means all the slots have equal probability of filled with a ball and having no balls. All the probabilities are half. Someone has it. हाँ बोलो.
Putting I equals to n, we get the minimum probability. By putting I equals to like 0, we get 0. We get
Uh, Before we move to the next question, in case you have any clarifications with the QMCs, you can ask them after the deep thought is over. Please do not ask any clarifications to the question making team after they have presented the solution. You can ask if you have any queries, you can approach them later after the event is over. Thank you.
IIT Delhi, you're now left with outrageous Dreepy farm. Dr. U.B. Jajodia, a Pokemon professor, is studying an anomalous Dreepy population that evolves directly into Dragapult in one day. Further, a Dragapult releases one Dreepy per day for 2 days. It doesn't release any more Dreepy, as a Dragapult only has 2 Dreepy on its head. After a Dreepy is released, it evolves into Dragapult the next day. He started with 1 Dreepy on the first day and is tracking the number of Dreepy with each passing day. He doesn't count the DP still on the Dragapult's head. Let us denote the number of Dreepy on the nth day as AN. Define the asymptotic growth rate as R equals limit n tends to infinity an plus 1 by an. Prove that limit m tends to infinity mod of r raised to the power m minus round of r raised to the power m equals 0. Round of x means round to the nearest integer. For example, round 0.5 as 1. Do you have any doubts? Your time starts now. You all have 5 minutes left. You guys have 3 minutes left. A minute left.
Teams, your time is up. IIT Delhi, please come to the board and present your solution. You have 5 minutes and your time starts now.
Let an be the number of GP, Bn be the number of Daggerpolt with one head, and Cn be the number of Daggerpolt with two heads. So in the next day, both Bn and Cn will release one GP. So An plus 1 is equal to Bn plus Cn, and Cn will convert to Bn plus 1 in the next day, and the GP will go to Daggerpoint in the next day. So from this, I can write solving these three questions. An plus 1 is coming to be An plus An minus 1, which is basically Fibonacci series. This 1 plus An minus 1 by An. Taking limit tending to infinity, it will give R is equal to 0. So from here, R would be equal to 1 plus root 5 by 2.
Yeah, so we are question. Yeah, we are being asked about the quantity root 5 plus 1 by 2 power m minus round of this. So let us write root 5 plus 1 by 2 power m as I plus f, and let us take another f dash as 1 minus root 5 by 2 the whole power m. Let us add these two. So I plus f dash will be root 5 plus 1 by 2 the whole power m plus 1 minus root 5 by 2 the whole power m. Now when we expand this in terms of binomial, we can show that this is an integer, or directly by using Binet's formula we can also say that this is an integer. So yeah, terms cancel out, that's why we get that. So I plus f dash belongs to z. Now important thing to note is that this f dash tends to 0 as m tends to infinity. So since this is the case, f can either tend towards 0 or tend towards 1. In both these cases, we get a round of this. A round of I plus f will be equal to min of f comma, so equal to min of f comma 1 minus f, which is 0 for both the cases. So yeah, that completes. Yeah, so 0.999x rounds off to 1, and rounds off the next integer, so the difference is the round of that is 0. The difference between this and the round of this is 0. Yeah.
Please wait for the time to finish, then you can start presenting.
Seconds left.
One thing I forgot to say was that this thing
is nothing but Fibonacci number of n according to Binet's formula. And we know that Fibonacci number of n is always an integer, so I plus f dash is always an integer. From there, this follows.
IIT Delhi, your time is up. IISER Kolkata can now present their solution. You have 3 minutes and your time starts now.
We are substituting a DP by A and a Dragapult by B. So on the first day we have 1A. On the next day he evolves to B, and from that B we get 1A and 1A on the next of the day, and this A again evolves to B. So what we can see is that on day 1 we have A1 is equal to 1. A2 there is no DP, so A2 is equal to 0. A3 is equal to 1 again. A4 again is equal to 1, and in this way the series will continue. So after some time, what we can find out is that when we go to higher numbers, like A3 by A2 is coming out to be infinity, so we will reject this case from here, although nothing explicit is mentioned in the question. A4 by A3, however, it is equal to 1. So if we try to do that summation at an plus 1 by an, it will be coming very much close to 1, because actually it will be greater than 1. When it will be greater than 1, it will be greater than 1 because A11 is equal to 4, A12 is equal to 4, A13 is equal to 6, A14 is equal to 8. Now 8 by 6, and in this way it will increase and increase and increase. At no time it can happen that it will be less than 1 when n tends to infinity. So R is equal to limit n tending to infinity an plus 1 by an. Now this term will be approaching 2, but it will not be exactly equal to 2. Limit m approaching infinity r to the power m minus round r to the power m, this will be equal to limit m tending to infinity. Since this will be approaching 2 and not close to 2, when m is approaching infinity, then this value will be approaching 2 to the power m minus the round of
30 seconds left.
Again will be approaching 2 to the power m. We can do a binomial expansion as well, but what we will see that ultimately it will converge to a series. It will be a convergent series which will get cancelled out, and the answer we will get as 0. Thank you.
Please wait for the time to get over. You can now present your answer. You have 2 minutes. And your time starts now.
Let us first assume that an equals to the number of GP on the nth state, bn equals to number of Dragapult which have 1 head, and cn equals to number of Dragapult which have 2 heads. So now obviously an equals to bn minus 1 plus cn minus 1. In minus 1 today, the 1 head Dragapult and 2 head Dragapult is being converted into 1 GP. Bn minus 1 will be equals to cn minus 2, because the 2 head Dragapult will be converted to 1 head Dragapult in 1 day, and cn minus 1 will be equals to an minus 2, because the n minus the Dragapult on the n minus the GP on the n minus 2 day will evolve into a 2 head Dragapult on the next day. So we have an equals to bn minus 1, that means cn minus 2 plus cn minus 1, which is an minus 2. Again cn minus 2 from this relation will be equals to an minus 3 plus an minus 2. Now as an equals to an minus 2 plus an minus 3, so we have assumed that the limit of an by an plus 1 by an as n tends to infinity equals to r. So as n tends to infinity, we will get, we divide both sides by this, an minus 2
Left.
an minus 1 plus an minus 3 minus 1. So this will be, so the equation that we would be getting will be this, and if we simplify this, we would be getting this, r cube equals to r plus 1. So the root of this equation will be the value of r. Now if r is that,
Time is up. IIT Bombay, you can now present your solution. You have 2 minutes, and your time starts now.
So first of all, we'll get a recursion for the number of repeats at the nth day. So if we start at day 1, we'll have a 1 repeat. Day 2 we have 1 Ragapolt, and day 3 we have 1 Ragapolt, 1 repeat. So the recursion we get, the small n denotes the number of repeats, and capital N denotes the number of Dragapolt, new Dragapolt generated at that day. So it will be equals to dn minus 1 plus dn minus 2. And dn, the number of new Dragapolts generated on that day, will be equal to the number of repeats on the day before it. So we will get capital Dn equals to dn minus 1. We will get dn equals to dn minus 2 plus dn minus 3. And solving this recursion, we get dn equals to a alpha raised to power n plus b beta raised to power n plus c gamma raised to power n.
We'll have some kind of solution like this where a, alpha, b, beta, c, gamma are unknowns, and it would correspond to the roots of equation x cube minus x minus 1 equals to 0. If we solve it, the graph goes somewhere like this, and at and at 0 and 1 we have value equals to minus 1. So
30 seconds left.
Alpha, beta, like we have 3 roots, 2 of which are between 0 and 1. So when it tends to infinity, those 2 factors would be negligible. Hence, we get some root here, which is alpha greater than 1. And this root also turns out to be, in fact, quite close to 1. So we can write it like I plus f, and I don't have time, but like if we do a
Your
similar
time is
solution
up.
to that.
The floor is now open for questions from the judges. We request a member from the question-making team to present the correct answer on stage.
Right. Okay. Sure. Okay, yeah. So, the correct recurrence, the relation that you get if V is the number of repeats would be Vn equals Vn minus 2 plus Vn minus 3. It's the Van der Waals sequence, not the Fibonacci. You can, of course, divide this by Vn minus 3, and you will end up with rho to the power 3 equals rho plus 1 if you take n tending to infinity. Solving this, you will notice that it has only one real root, r, and that real root is greater than 1. You can plot it, and you can just use calculus, figure out this is negative, and the root is greater than 1. So we'll get, so since r is the root of this, we'll take x minus, so x cube minus x minus 1 equals 0. We can write it as x square plus rx plus 1 by r, since r is a root of this, and this will have 2 complex roots, z and z conjugate. We can see that z mod is equal to square root of z conjugate, which is square root of 1 by r, which is less than 1. And now, from this equation, x cube minus x minus 1 equals 0, we'll see that r plus z plus z mod is an integer because it's going to be 0. We'll get rz plus z mod plus z mod r is -1, and z mod is 1. All of these are integers. And if you can write, if you write, I'm just using simpler notation, you can easily see that g of n equals the first thing times g of n minus 1 plus the next thing times g of n minus 2, n minus 3. These are just these relations here, r plus z mod and r z mod. You can write it like this. It's an expansion. This is probably the hardest part to figure out. But once you've done this, you will see that all gn will be integers. All of these numbers will be integers for all n. And so now I can define a function f of x, which is simply x minus round of x. And since this is an integer, I'll say it's an integer cn. I'll get r power n equals cn minus z power n minus z mod n. I can simply apply the function. And this function here, notice I can just take the integer out because so round x doesn't matter, and it's an even function. It's continuous too. So that's why you can do this. And now you can simply take the limit. Frn, and this thing here, the mod of f z is less than 1. Hence this goes to 0 in the limit. So
With that, we conclude the deep thought round for Math Mimamsa. Thank you to everyone for attending.
We would once again like to extend our gratitude to Professor Steven Spallone and Dr. Rabia Basu for judging the mathematics deep thought. And we also sincerely apologize for the delay. And also the quizzing events for today are over, teams. So your team coordinators will be escorting you for to the mess or to the guest house, depending on how you want to have dinner. So yeah, that's all. Thank you guys once again. And also a special thanks to all the volunteers and coordinators.